Have you ever wondered how you are able to hear the sweet chirping of birds or the melodious notes of your favorite song? Today we're embarking on an auditory adventure to explore the science of hearing. Our journey will take us from the moment sound waves are created, all the way to the magical process that allows us to perceive sound. We'll delve into the intricacies of our ears and the marvels of our auditory system. So buckle up and stay tuned as we unravel the mystery of how sound is perceived. Sound perception begins with the journey of sound waves. It all starts with vibrations. Imagine a guitar string being plucked, a drum being struck, or simply the human voice box in action. These vibrations disturb the surrounding air particles, setting off a chain reaction. This chain reaction creates a series of compressions and rarefactions, forming what we know as sound waves. Think of it like ripples spreading out on a calm lake after you've thrown a stone into it. These sound waves are not confined to just air. They can travel through a variety of mediums, including water and even solid objects. Their speed varies depending on the density and temperature of the medium. For instance, sound travels faster in water than in air, and even faster in steel. These waves, carrying the symphony of the world, then reach our ears. But that's just the beginning. Stay tuned as we dive into the fascinating intricacies of our auditory system in the next segment. Our ears, intricate and beautifully designed, are the gatekeepers of sound. To appreciate how we perceive sound, we need to delve into the three main parts of the ear: the outer, middle, and inner ear. Starting with the outer ear, or the pinna, it's the part we see, the sentinel standing guard, collecting sound waves and guiding them into the ear canal. This narrow passage, lined with tiny hairs and glands, carries the sound waves towards the eardrum, serving as a conduit for these vibrations. Next, we encounter the middle ear, a small air-filled chamber just beyond the eardrum. Here, a trio of tiny interconnected bones, the malleus, incus, and stapes, collectively known as the ossicles, take center stage. These bones are the unsung heroes of our auditory system, amplifying the vibrations from the eardrum and transmitting them to the inner ear. Finally, we reach the inner ear, the master of transformation. Nestled within is the cochlea, a snail-shaped structure filled with fluid and lined with specialized sensory cells, the hair cells. When the amplified vibrations reach the cochlea, they stir the fluid, stimulating the hair cells. This stimulation converts the mechanical vibrations into electrical signals, a language our brain can understand. Our ears, each section playing its vital role, act in harmony to transform sound waves into the symphony of sounds we experience every day. Now that we've explored the ear's structure, let's delve into the auditory system's functions. The auditory system, a marvel of nature, interprets the sound waves into something we can understand. Let's take a closer look at this intricate process. The journey begins in the cochlea, a snail-shaped structure in our inner ear. Here, mechanical vibrations are converted into electrical signals by specialized sensory cells, known as hair cells. The hair cells dance in response to the fluid movements caused by the vibrations, generating electrical signals that are as unique as the sounds we perceive. These signals are then picked up by the auditory nerve, a bundle of nerve fibers that serves as a biological information highway, carrying the signals straight to the brain. Within the auditory cortex, our brain's sound processing center, these signals are interpreted as distinct sounds. This complex process allows us to recognize voices, appreciate music, and respond to various auditory cues in our environment. Sound perception, however, is more than just hearing. Sound perception is the brain's ability to interpret and comprehend the various attributes of sound. This is where the magic truly happens. Our brains receive the electrical signals from our auditory nerves and begin the complex process of decoding these signals into meaningful sound. Think of the brain as a masterful orchestra conductor, meticulously interpreting each note. It distinguishes between different frequencies, recognizing them as varying pitches. It perceives changes in amplitude as differences in loudness. The brain can even discern the unique timbre of sounds, enabling us to tell the difference between a violin and a saxophone playing the same note. This incredible ability extends beyond music. It allows us to recognize the subtle nuances in human speech, the rustling of leaves in the wind, or the distant rumble of thunder. It's an intricate symphony of neurology and biology that lets us navigate and appreciate the world around us. Next time you enjoy your favorite song or the simple sounds of nature, remember the intricate process that enables you to perceive these auditory wonders.